विद्यार्थियों ਤੁਹਾਡਾ ਅੱਜ ਦੀ ਕਲਾਸ ਵਿੱਚ ਸਵਾਗਤ ਹੈ। ਅੱਜ ਅਸੀਂ ਕੋਲੋਇਡਸ ਬਾਰੇ ਗੱਲ ਕਰਾਂਗੇ। ਆਪਣੀਆਂ ਪਹਿਲੀਆਂ ਕਲਾਸਾਂ ਵਿੱਚ ਅਸੀਂ ਮੈਟਰ ਦੀਆਂ ਕੋਲੋਇਡਲ ਸਟੇਟਸ ਬਾਰੇ ਕਾਫੀ ਕੁਝ ਸਿੱਖਿਆ ਸੀ। ਟਰੂ ਸੋਲਿਊਸ਼ਨਸ, ਕੋਲੋਇਡਸ ਅਤੇ ਸਸਪੈਂਸ਼ਨਸ ਦਰਮਿਆਨ ਡਿਸਟਿੰਕਸ਼ਨ ਨੂੰ ਜਾਣਿਆ ਸੀ ਅਤੇ ਕੋਲੋਇਡਸ ਦੀ ਕਲਾਸੀਫਿਕੇਸ਼ਨ ਬਾਰੇ ਵੀ ਪੜ੍ਹਿਆ ਸੀ। ਆਓ ਅੱਜ ਇਹ ਜਾਣੀਏ ਕਿ ਕੋਲੋਇਡਲ ਸੋਲਸ ਕਿਵੇਂ ਤਿਆਰ ਕੀਤੇ ਜਾਂਦੇ ਹਨ। पर अगे वधन तो पहला आज दी क्लास दे लर्निंग ऑब्जेक्टिव्स जान लईए।
On completion of this topic, learners will be able to classify colloids into lyophilic and lyophobic colloids. Describe preparation of colloids by physical and chemical methods. Explain methods of purification of colloids like dialysis, ultrafiltration, and ultra-centrifugation.
Let us now learn about the general methods of preparation of colloidal sols. ਕੀ ਤੁਸੀਂ ਲਾਇਓਫਿਲਿਕ ਅਤੇ ਲਾਇਓਫੋਬਿਕ ਕੋਲੋਇਡਲ ਸੋਲਿਊਸ਼ਨਸ ਜਾਂ ਸੋਲਸ ਬਾਰੇ ਜਾਣਦੇ ਹੋ, ਜਿਨ੍ਹਾਂ ਨੂੰ ਆਮ ਤੌਰ ਤੇ ਵੱਖ-ਵੱਖ ਮੈਥਡਸ ਰਾਹੀਂ ਤਿਆਰ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਆਓ ਪਹਿਲੇ ਇਹਨਾਂ ਤੇ ਵਿਚਾਰ ਕਰੀਏ। ਪ੍ਰੀਪਰੇਸ਼ਨ ਆਫ ਲਾਇਓਫਿਲਿਕ ਕੋਲੋਇਡਸ। ਵਿਦਿਆਰਥੀਓ, ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਕਿ ਅਸੀਂ ਲਾਇਓਫਿਲਿਕ ਕੋਲੋਇਡਸ ਦੀ ਪ੍ਰੀਪਰੇਸ਼ਨ ਬਾਰੇ ਵਿਚਾਰ ਕਰੀਏ, ਕੀ ਤੁਸੀਂ ਆਪਣੇ ਪਹਿਲੇ ਗਿਆਨ ਨੂੰ ਧਿਆਨ ਵਿੱਚ ਰੱਖ ਕੇ ਮੈਨੂੰ ਲਾਇਓਫਿਲਿਕ ਕੋਲੋਇਡਸ ਸ਼ਬਦ ਦਾ ਮਤਲਬ ਦੱਸ ਸਕਦੇ ਹੋ? The word lyophilic means affinity for solvent. Thus, when such substance is mixed with a suitable solvent, lyophilic sol is obtained. Lyophilic colloids are reversible in nature because these can be precipitated easily and directly converted into colloidal state by addition of dispersion medium. These have strong affinity between particles of dispersed phase and dispersion medium. ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਸੀਂ dispersed phase ਅਤੇ dispersion medium ਬਾਰੇ ਜਾਣਦੇ ਹੋ। Dispersed phase is a substance present in small proportion and consists of particles of colloidal size that is 1 to 100 nanometer. The dispersion medium is the medium in which the colloidal particles are dispersed. Let us take an example in a colloidal solution of sulfur. Sulfur particles constitute the dispersed phase and water is the dispersion medium. Thus, lyophilic colloidal solutions are readily formed by simply mixing the dispersed phase and dispersion medium under ordinary conditions. For example, the substances like gelatin, gum, starch, egg albumin give colloidal solution like water. Let us now have a look at the preparation of lyophobic colloids. ਕੀ ਤੁਸੀਂ ਮੈਨੂੰ lyophobic colloids ਦਾ ਮਤਲਬ ਦੱਸ ਸਕਦੇ ਹੋ? The word lyophobic means less affinity for solvent. Substances like metals, their hydroxides or sulfides etc., when simply mixed with the dispersion medium, do not pass directly into a colloidal state. They have to be prepared by special methods. Lyophobic sols are not very stable and are readily precipitated. Therefore, preparation of lyophobic colloids involves two types of methods, which are dispersion methods, condensation methods. Let us first discuss the dispersion method. In dispersion method, colloidal particles are obtained by breaking large particles of a substance in the presence of a dispersion medium. Can you tell me what the nature of sols will be? Yes, you are right. The sols formed are unstable. Do you know how they can be made stable? They are stabilized by adding stabilizing agents. Few dispersion methods are mechanical dispersion, electrical dispersion, peptization. Let us discuss them. Mechanical dispersion. In this method, the substance is first ground to coarse particles. It is then mixed with the dispersion medium to get a suspension. The suspension obtained is grinded in a colloidal mill or a ball mill or an ultrasonic disintegrator. Let us have a look at animation to see what happens to suspension in a colloidal mill.
As you can see on the screen, the colloidal mill consists of two metallic discs nearly touching each other and rotating in opposite directions at a very high speed of about 7,000 revolutions per minute. The space between the discs of the mill is so adjusted that coarse suspension is subjected to great shearing force, giving rise to particles of colloidal size. Colloidal solutions of black ink, paints, varnishes, dyes, etc. are obtained by this method.
The next one is electrical dispersion or Briggs arc method. This method is used to prepare soles of metals such as platinum, silver, copper or gold. Let us have a look at the animation to see the details of this method.
The metal whose solution is to be prepared is made as two electrodes immersed in dispersion medium such as water. The dispersion medium is kept cooled by surrounding it with a freezing mixture. An electric arc is struck between the electrodes. The tremendous heat generated by the arc vaporizes the metals, which are condensed immediately in the liquid to give colloidal solution, which means that particles of colloidal size are formed. The colloidal solution prepared is stabilized by adding a small amount of KOH to it. Let me now ask you a question. Name two colloids that can be prepared by Briggs arc method. Answer is gold and platinum.
Let us now have a look at the third method of dispersion, that is by peptization. अपने पहले ज्ञान ਨੂੰ ਧਿਆਨ ਵਿੱਚ ਰੱਖ ਕੇ ਕੀ ਤੁਸੀਂ ਮੈਨੂੰ ਪੈਪਟਾਈਜ਼ੇਸ਼ਨ ਬਾਰੇ ਦੱਸ ਸਕਦੇ ਹੋ? I'm sure you are aware that the process of converting a freshly prepared precipitate into colloidal form by the addition of a suitable electrolyte is called peptization. The electrolytes used for the purpose are called peptizing agents. Do you know the cause of peptization? Let me explain it to you. When an electrolyte is added to a freshly prepared precipitate, the suitable ions from the added electrolyte are absorbed on the surface of particles of the precipitate to form charged particles. These charged particles repel one another and form colloidal solution. Let us have a look at the equation. On treating a precipitate of ferric hydroxide, that is FeOH thrice, with a small amount of electrolyte, that is ferric chloride solution, a reddish brown colored colloidal solution is formed. In this case, Fe3 positive ions from ferric chloride are absorbed by precipitate of ferric hydroxide to form a sol. Let us us take another example. A precipitate of silver chloride can be peptized by shaking with a dilute solution of silver nitrate to give a colloidal solution of silver chloride. You can observe this in the equation. Here silver ions from the electrolyte get absorbed on the surface of silver chloride precipitate to form a colloidal solution. आओ लायोफोबिक सोल्स की तैयारी लई वरते जांदे दूजी टाइप दे मैथड ते एक नज़र मारिए जो है कंडेंसेशन मैथड. In condensation method, particles of atomic or molecular size are induced to combine to form aggregates of colloidal dimensions. To achieve this, chemical as well as physical methods are employed. Chemical methods can further be categorized into oxidation, reduction, hydrolysis, double decomposition, and physical methods includes excessive cooling, exchange of solvent, and change of physical state. By chemical methods, let us take up the first chemical method, that is oxidation. The colloidal solutions of metals are obtained by oxidation of their compounds. For example, a colloidal sol of sulfur is obtained by bubbling hydrogen sulfide gas through the solution of oxidizing agents like bromine water or sulfur dioxide. The equations shown on the screen represent the process. Let us now discuss the next method, which is reduction. The colloidal solutions of metals are obtained by reduction of their compounds. For example, a solution of gold 3-chloride is reduced with tin 2-chloride to form a sol of gold. The equations shown on the screen represent the process. The reaction can also be carried out with formaldehyde or hydrazine as shown on the screen. Here a solution of gold 3-chloride is reduced with formaldehyde or hydrazine to form a sol of gold. The gold sol thus prepared has a purple color and is called purple of Cations. Colloidal sols of platinum, silver, etc. can also be prepared in a similar way, that is by reduction of their compounds. Let us now learn the third process, that is hydrolysis. In this, a colloidal solution of ferric hydroxide is prepared when a concentrated solution of ferric chloride is added drop-wise to hot water. The equations shown on the screen represent the process. Next we come to the double decomposition. In this, colloidal sol of arsenious sulfide, that is As2S3, is obtained by passing hydrogen sulfide, that is H2S, through dilute solution of arsenious oxide in water solution as shown on the screen. ਹੁਣ ਅਸੀਂ ਲਾਇਓਫੋबिक सोल्स ਦੀ प्रिपरेशन ਲਈ कंडेंसेशन मैथड्स ਦੀ ਦੂਜੀ टाइप ਤੇ ਆਉਂਦੇ ਹਾਂ, by physical methods. Let us now discuss the first one, where by excessive cooling, a colloidal solution of ice in an organic solvent like ether or chloroform can be prepared by freezing a solution of water in the solvent. The molecules of water, which can no longer be held in solution separately, combine to form particles of colloidal size. The next one is by exchange of solvent. Colloidal solution of certain substances such as sulfur, phosphorus, which are soluble in alcohol but insoluble in water, can be prepared by pouring their alcoholic solution in excess of water. For example, alcoholic solution of sulfur on pouring into water gives milky colloidal solution of sulfur. The last one is by change of physical state. Salts of substances like mercury and sulfur are prepared by passing their vapors through a cold water containing a suitable stabilizer such as ammonium salt or citrate. Children, let us take up purification of colloidal solutions. ਕੀ ਤੁਸੀਂ ਉਹ ਤਰੀਕੇ ਜਾਣਦੇ ਹੋ ਜਿਨ੍ਹਾਂ ਰਾਹੀਂ colloidal solutions ਨੂੰ purify ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ? Colloidal solutions ਨੂੰ ਤਿਆਰ ਕਰਨ ਦੇ ਤਰੀਕੇ ਜੋ ਅਸੀਂ ਹੁਣ ਤੱਕ ਪੜ੍ਹੇ ਹਨ ਵਿੱਚ impurities ਖਾਸ ਕਰਕੇ electrolytes ਹੁੰਦੇ ਹਨ। ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ impurities ਦੀ ਮੌਜੂਦਗੀ ਦਾ salts ਤੇ ਕੀ ਇਫੈਕਟ ਪਏਗਾ? ਹਾਂ, ਤੁਸੀਂ ਠੀਕ ਹੋ। Impurities salts ਨੂੰ destabilize ਕਰ ਦੇਣਗੀਆਂ। Colloidal solutions ਨੂੰ stable ਬਣਾਉਣ ਲਈ ਇਹਨਾਂ impurities ਨੂੰ eliminate ਕਰਨਾ ਹੀ ਪਏਗਾ। To sum up, the process of reducing the impurities of the electrolyte to the minimum required level is known as purification of the colloidal solution. Let us discuss few methods for the purification of colloidal solutions. Let us learn about the first one, that is dialysis. The process of separating the particles of colloids from those of crystalloids by means of diffusion of the mixture through a parchment or an animal membrane is called dialysis. Do you know the principle behind it? Its principle is based upon the fact that colloidal particles cannot pass through a parchment or cellophane membrane while the ions of the electrolyte can pass through it. The colloidal solution is taken in a bag made of cellophane or parchment. The bag is suspended in fresh water. The impurities slowly diffuse out of the bag, leaving behind the pure colloidal solution. The distilled water is changed frequently to avoid accumulation of the crystalloids, otherwise they may start diffusing back into the bag. Notice the inlet and exit point of water in the diagram. Dialysis can be used for removing hydrochloric acid from ferric hydroxide sol. Let us have a look at the animation to have a better understanding of the subject.
The animation here depicts one of the different methods by which solutions can be purified. In the process of dialysis, separation of impurities from colloids from crystalloids take place. You can see on the screen a colloidal solution kept in a container. The impurities in the solution are highlighted in yellow. These impurities destabilize the solution. Separation is shown with the help of a parchment paper. The parchment paper with the solution is kept in a container containing fresh water. Let us have a look at the processes taking place at the micro level. Parchment paper has a pore size. The particles smaller than or equal to the pore size will pass through the pores, while those which are bigger than the pore size cannot be able to pass through them. You will see the impure particles coming out of the parchment paper.
Let us now have a look at the process of electrodialysis. ਤੁਸੀਂ ਟਰਮ ਇਲੈਕਟ੍ਰੋਡਾਇਲਿਸਿਸ ਤੋਂ ਕੀ ਸਮਝਦੇ ਹੋ? ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਸਾਰਿਆਂ ਨੂੰ ਪਤਾ ਹੈ ਕਿ ਇਸ ਦਾ ਮਤਲਬ ਹੈ ਇਲੈਕਟ੍ਰਿਸਿਟੀ ਦੀ ਮੌਜੂਦਗੀ ਵਿੱਚ ਡਾਇਲਿਸਿਸ ਕਰਨਾ। ਡਾਇਲਿਸਿਸ ਦਾ ਪ੍ਰੋਸੈਸ ਸਲੋ ਹੁੰਦਾ ਹੈ To increase the process of purification, the dialysis is carried out by applying electric field. This process is called electrodialysis and is shown on the screen. It consists of a colloidal solution containing crystalloid as well as sol particles present in the parchment paper. It also consists of an inlet and outlet for water. When an electric field is applied, we find that crystalloid particles move out of the parchment paper under the influence of the electric field, which are carried away by water through the outlet to keep the water inside the container clean. Let us recap this process by looking at an animation to understand this well.
Children, here you are observing the process of electrodialysis. You can see on the screen an anode, a cathode, the colloidal solution. In electrodialysis, it is shown that impurities are removed from the colloidal solution by the flow of electric current. There is a cation exchange membrane. You can see the cation exchange membrane highlighted in yellow. Look at the movement of cations and anions in the solution. The resulting solution is demineralized, which is highlighted in yellow. Concentrated liquid and the demineralized solution are removed from bottom, which is permeable to cations.
Let us take an example. Kidneys in the human body act as dialyzer to purify blood, which is of colloidal nature. The most important application of dialysis process is the artificial kidney machine used for the purification of blood of the patients whose kidneys have failed to work. The artificial kidney machine works on the principle of dialysis. As you can see on the screen, the dialysis membrane in the machine allows small particles of excess ions and waste products to pass through, while it does not allow the colloidal size particles such as hemoglobin to pass through the membrane. विद्यार्थियों, आओ हुन ultrafiltration दी process बारे जानिए. It is the process of removing the impurities from the colloidal solution by passing it through graded filter papers called ultrafilter papers. These filter papers are permeable to all substances except colloidal particles. Colloidal particles can pass through ordinary filter paper because the size of the pores is too large. However, the size of the pores of filter paper can be reduced by impregnating them with colloidine or gelatin solution to stop the flow of colloidal particles. The colloidine solution generally used is 4% solution of nitrocellulose in a mixture of alcohol and ether. Preparation of ultrafilter paper. An ultrafilter paper may be prepared by soaking the filter paper in a colloidine solution, hardening the dipping in formaldehyde solution, and then finally drying it. A series of graded ultrafilter papers may be obtained by using the impregnating solutions of different concentrations. With these ultrafilter papers, impurities of different sizes can be effectively removed. In this method, sol is poured over the ultrafilter, which allows solution of impurities to pass through, but retains the colloidal particles. The colloidal particles left on the ultrafilter paper are then stirred with fresh dispersion medium, that is solvent, to get a pure colloidal solution. This is a slow process, and to speed up the process, pressure or suction is applied. Let us have a look at the animation to understand it better.
Ultrafiltration. Filter papers obtained by treating them with colloidal are called ultrafilters. Filtration through ultrafilters is called ultrafiltration. In ultrafiltration, the ultrafilter is supported over a wire mesh and the impure solution is poured over it. The impurity particles, that is, the electrolytes, pass through the ultrafilter while the larger colloidal particles are retained. The process is very slow. However, it can be increased by applying pressure on solution side or by using a suction pump on the filtrate side. By using a series of graded ultrafilters, impurities of different size can easily be removed, and it is even possible to separate colloidal particles of different size from one another.
Ultra-centrifugation. In this method, the colloidal sole is taken in a tube which is placed in an ultra-centrifuge. On rotation of the tube at high speeds, the colloidal particles settle down at the bottom of the tube, and the impurities remain in the solution called centrifugate. The settled colloidal particles are removed from the tube and are mixed with an appropriate dispersion medium to regenerate the sole. Thus, the pure sole is obtained. In other words, we can say that ultra-centrifugation involves the separation of colloidal particles from the impurities by centrifugal force.
In the process of ultracentrifugation, separation of colloids and crystalloids are shown. In the process of ultracentrifugation, it is shown that the impure colloidal solution is centrifuged at 60,000 revolutions per minute for hours, and the impurities are separated out. The colloidal particles are collected at the top, whereas the impurities are collected at the bottom. You can observe the difference on the screen.
ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਸੀਂ ਸਾਰਿਆਂ ਨੇ ਹੀ ਅੱਜ ਦੇ ਇਸ ਪਾਠ ਦਾ ਆਨੰਦ ਮਾਣਿਆ ਹੈ। ਵਿਦਿਆਰਥੀਓ, ਧਿਆਨ ਦੇਣ ਲਈ ਧੰਨਵਾਦ। ਅਗਲੀ ਕਲਾਸ ਵਿੱਚ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ। ਤਦ ਤੱਕ ਲਈ ਇਜਾਜ਼ਤ ਦਿਓ।